Welcome back, dear friends, to another exciting episode. I'm having such a great day. Oh, and thank you for all the kind and encouraging comments to the last video. This is just so enjoyable. Getting exciting laser parts cut out. Finally putting these gauges, the decorative gauge backs, into plastic bags whilst watching a really boring film called Pig with Nicolas Cage. It's about a morose man who finds truffles with his special pet pig, and then someone steals the pig, and then he becomes even more morose and miserable. Oh, I think I'd started watching it ages ago and I just thought, oh well, let's just see how it goes. It's really boring, and there's not even any spaceships in it. How ridiculous. That's better. I've just found another film, Gangster #1. Made in 2000 or something. It's got Malcolm McDowell in it. It's about gangsters, and I've never seen it. Brilliant. And oh, just even the start. You know, when you're watching a film, you can see instantly whether it's going to be any good. The introduction is fantastic. Oh, brilliant. It's another day, and the sunbeams are shining through the window in a glorious fashion. How lovely. You can see all the dust just waiting to settle on painted surfaces. So today's job, without further prevarication, I need to glue these opaque white sections, the light guides sort of, sounds a bit posh, into the slots on the black piece of acrylic. And what I also decided to do with this very morrow whilst walking the dog, getting inspiration, I was going to have to paint the edges of this, because I want the top to be paint free so I can glue that on with the captive screws in, which I must remember to put in first. And I was thinking, well, I'll have to paint that then without painting these bits, but they have to be glued on first. And I thought, hold on a minute. It will look lovely with a little black trim around the outside. That can be painted brass, as can the edges of that. But there's just a little black section. I think that'd look lovely. And naturally, dear friends, I'm going to use my favoured form of glue, which is the super variety. Because it's so thin, it gets drawn into any joints, which is very handy, especially with this sort of job. I've glued one in because I know if the camera's on it'll all go horribly wrong, and I just wanted to check how I was doing it. Obviously a couple of bits of packing tape on the table to stop it sticking to that. I cut out some new ones, because the original ones were just too small. I said before, 0.25mm laser width all round. It's a bit of a gap, so I've cut out 3 more that are 0.1mm larger all round, and they just push in nicely. So this time I'm leaving the protective film on the top as well. There we are. Oh no, I don't know whether I mentioned it, I did countersink the holes for the little M3. M3 countersunk screws sticking through, 1, 2, 3, 4, just to fix it all down to the base, because I do want, as always, to be able to unscrew and remove all this from the wooden base. Now, whilst they are sticking themselves to the table, I am going to sort out the wood. The original one obviously had a wooden base, so is this one. And I had this lovely offcut of plywood, really good quality, very well made and stable. So what I'm going to do, it's the first time ever I've tried to do this, so I'm going to use the laser cutter to mark it out. So there's the final wooden part, the base design. I just copied across where all the holes needed to be. My laser is 60 watts. I use it at a maximum of 40% because the company said it would last longer, and it certainly has. The optics on a laser tube are as good today as they ever were about 7 or 8 years ago. So I'm just going to use it to mark it out. Let's just check there's enough room. Yeah, being 60 watt, there's no way it could cut through this. So I stop. It's just going to basically line engrave, mark it out. Oh, lovely. And then I can use wonderful hand tools. Hand tools? to actually cut out slots and things like that. That's lovely. So pleased that that idea came to me. So, that's beautifully marked out, isn't it? Oh, what a joy. I have to say, I was very impressed with the bandsaw and the laser cutter, because I went along and it just touched the line right the full length, which is lovely. So I can now sand off the four corners, drill the holes, and then start thinking about these slots. Now I need to make a hole for the potentiometer, but the potentiometer shaft won't fit through that. The nut bit, or whatever you call it, I can't think. So I'm going to use the lovely Forstner bit to drill a clearance hole at the back. I've just drilled a 2mm hole through from the front, so I know where it's going to go. Look at that. Forstner bits are just amazing, because you get completely flat bottoms, and you can't beat a flat bottom. So I set the depth stop on the pillar drill so I know how much to leave, which is about 5mm. Now I can go ahead and drill that out to 7. Now I've got to drill all these slots out, and for the life of me I can't think of any magical tool, powered or hand tool, that I could use other than a drill bit. So what I'm going to do is to drill several 4mm holes and then just join them up. It's not elegant, but none of this will be seen, so it'll be good enough. That'll do nicely. It's only, after all, for the wires to come through to connect to each end of the LED strips. I could have clamped the wood into my cross-sliding vice thing, but because I'm using the wrong tool for the job, the 4mm diameter high-speed steel drill bit, and I would then have no sort of feedback about pressures and stuff, and I'm just happily turning away, this is going to snap definitely, without a shadow of a doubt. Whereas if I do it by hand, it's lovely, and I've just realised I can use a countersink to put a radius or whatever around the edges. I reckon it's time to start painting and decorating. So that's all glued together and doesn't need painting and decorating. I've stained the base just around the edges because obviously I want to glue on the LED strips up there. So now I can spray these two. There's the front panel that all needs to be sprayed. I've masked off this because I only want the little bits you're going to see where it steps out and the edge showing because I want to be able to glue onto that. Let's get that painted. I've been thinking about the base, and I've been thinking about wires, because this is going to sit onto a raised section, a solid wooden raised section on Ben's radio cabinet. So I don't want him to have to drill too many holes for all sorts of stuff. And if I put wires all over the back, it's just going to mean he has to cut a bigger hole. So what I'm going to do, any excuse, I'm going to use the router and a 1/2 inch, 12 point whatever millimetre bit, slot cutter to just cut some slots around here. Just cut some slots. Freehand, off the grid, or whatever else. Now I have done it before, because when I made the bookcase out of the old science tables and calculated from the ring growth and diameter and things, when they were planted, when they were felled, when they were turned into tables, etc. I did all that, I think, with this particular router and a little pointy bit on the end, just by following lines that I'd drawn out for the letters, and it worked well. I just need room for 3 wires, that's 3. The plus 5 volts, 0 volts and the signal, so I don't need that much space. Well, that's not too shabby. It's not going to be seen, as I say, but that's great. All the wires and everything can be rebaited, and I can screw the Arduino just on the middle in the back, so there's just really one hole and a little bit of clearance for the potentiometer. Now, the most exciting thing is I can start sticking things down. But of course, I stupidly forgot to mark on this base where the LED strips go. I know they go between the holes, but I've just cut out a piece of scrap card. I'll fix that in place and I can get them stuck down and then wired up. Got them marked out. Next thing, I'm just going to have to do it, aren't I? I'm just going to have to cut the end off and start cutting this up into the right length and just hope that I am not making a disastrous mistake. This is so exciting. I can't tell you. You just cut them with a pair of scissors where you want them. I'm sticking them down with this Bostik multi-purpose glue because it's sort of spirit based. It's sort of contact adhesive, because the back of this is really shiny and I don't think super glue will stick it, or many other types. So that's going to be nice. So I've got the arrows all pointing this way. I know it means that I then have to have a data wire running back to the next lot, but just for programming it could have been back to front alternating, but then it obeyed the program. As this one went across, this one would in fact have to go backwards, and then that one. So I ended up just doing it like that. So it goes across, that'll connect to there, that'll connect to there, that'll connect to there, and then that will connect to there and around. And that's it. That's what I'm going to do now, because I've got some wires, a soldering iron, and very little solder left. Oh, lovely. I'll get back to you once I've wired it up. The moment of truth is upon me. I've got them all wired up and it's time to see what happens. I'm pretty pleased with how that's gone. It's all connected up nicely. Connected, all the wires go through the bits at the end, and the power just goes in at this end. That's fine, but the data goes in there, out, there. I seem to remember reading somewhere that the data line shouldn't be too long. So, time to switch it on. Switch on the laptop first, because that's going to power the Arduino via the USB wire. The Arduino ground is connected to the ground power supply ground for all these. So what I need to do now is to press this button here. I will give you a front roadside seat, or whatever it's called, ringside seat. Isn't that lovely? And the really incredibly exciting thing about all this is the potentially enormous potential it has, because now I know I can address each one of these LEDs individually. I can get it to do all sorts of different patterns, and I can have swirling things going on under the globe at that end. I mean, the sky's the limit. It's so exciting. The varnish finally arrived. Plastic coat, because I thought I'd get the same make as the paint I use. Gloss acrylic varnish. Now I wanted to be really careful, because I didn't want to risk spraying these two beautiful items with a varnish and then find that it reacted with it and ruined the whole paint job. So last night I painted some offcuts, which have been spray painted brass, and it's lovely. There's no effect, and I can feel it's really smooth, and that was only 4 light coats, and normally I'd do 8. That's great. There's a rejected gauge background because I've got glue all over it, and again that's absolutely fine. I'm so pleased, because it means I can spray varnish onto the pieces I made before to protect them, because if you remember, I think I might have mentioned it, if you touch the brass painted stuff lots of times with greasy fingers and things, you can see fingerprints sometimes appear. They can wipe them off, but the thought of it sitting being fiddled with by numerous young children, probably pretty filthy hands, I thought it wise just to give it a protective film of varnish. That's exciting. Live and learn new things every day. Time for another cup of coffee, I think, to engage the pride. So stupid. I was just moving these back onto here, the spray booths, that I could spray them, and noticed some specks of grit. Just 3 of them. So I thought, oh no, and sort of sanded, cut them off and everything. Then thought, well, I'm going to have to respray it, and then realised, of course, that they were inside the bit. This the taped off bit is just for the overlap, which is only a couple of millimetres, so they wouldn't have been seen anyway. What a fool! I told you. But the good thing about this brass paint, metallic brass basically, is it's dry in an hour. Oh, thank goodness for that. Don't want to spray the varnish till it's dry. Oh, what a faff. Still mustn't grumble, because whilst I'm messing about with paint, I can be programming these, which is also very exciting. That's what I love about these projects. You've got mechanics, you've got design, you've got electronics, you've got programming. What fun! Would you believe it? I've just found I've sprung a leak. It was a bit worrying. I've discovered the source. Somehow when I was cutting off the dust with a scalpel, I didn't even notice and didn't feel it. I sliced my thumb. Right, where's that super glue gone? I've been thinking about it, and the potentiometer has sort of movement, probably something like that. Doesn't go right to each end. So I reckon for the first part it's going to start off there. For the first part about there, I reckon that's going to be the blue, green, purple and thing, LEDs just moving across. Then it's going to have this bit, and I reckon all of that will be the white flickery dickeries, so getting more and more random white coming on. Once you reach the end, it's out of your hands, and the Arduino times all of the white suddenly shooting across to the bit that's going to go here on the left hand side, swirling around white and other colours and things for sort of 5 seconds. Oh, actually you can just keep going until that's reset back to the beginning. I think that's probably a good way to go. Good to have a plan, because now I know how to sort of start programming the Arduino. Got no idea. I'll get back to you when I've got some idea, hopefully. Right, where's that coffee? Actually, before I do that, to help me get my head around it, and also possibly to help you, I love a really simple example. So I've gone through their example and cut out everything just to get one LED hopefully working. So it starts off, this is the simplest sort of sketch you can get for this. There's include the Adafruit NeoPixel library. Then you define some variables with different things, which I'm always too lazy to do. The idea is you define them, and they're constants, so you can't ever change them in the rest of the sketch, but you can refer to them and get things to read them. Very handy, because for example, if you've got say several functions that all need to know the brightness of LED that you want, you don't have to keep putting it in like I do, because I've been too lazy or can't get my head around it. You just have a constant at the top, and then if you change that, all of the things that rely on that number will be changed automatically anyway. So your LED pin, which we've set to pin 4 on the Arduino that I'm using. The LED count says it's 60, it isn't actually, but I forgot to change that because I cut some off, it doesn't matter. And the brightness I want is 20. And then you create an instance, I think it's called, of the Adafruit NeoPixel thing. We've called it strip. I think you can call it almost anything you want, but strip, there we are, there's some constants read, LED counts, LED pin, and then several of these, it gives you a list underneath. These are other parts, references, to allow it to run different types of LED strip, which is brilliant. Then you have the setup, and that says strip, because that's the instance name. Begin, start it doing it. Strip show, and because we haven't written any data to it, that base, I think there's a big, well, an array about 60 long inside, created by this software library. That basically shows that, writes any data in it to the LEDs, and there isn't any, so it'll just switch them all off. And then strip set brightness to brightness, that's that. And then right at the bottom, loop, this is my little bit, poor contribution. Strip set pixel color. I'm going to tell it to LED 0 set to the color, and it sends 32-bit number off, combining these 4 different brightnesses of the 4 LEDs, 0 to 255. So that's why it's written in here, because that converts that to a 32-bit number, and I want it to be white, so it's 255. And then strip show. Then it loops round and round. It doesn't really have anything to do with it, but just proof of concept. So let's see whether we can upload that. Currently the LEDs are still running that standard pattern. So we go to here and we go to, well, compile and upload. Reflections, of course. That's now compiling it, and then it'll upload it. Let's see what it does. And there we are. Oh, it's such a joy. So there's 0. That's the first LED in this long chain, and it's switched the white one on. So let's get on and write a time travel sketch. I'll get back to you when I've got something. That's better. Most of the coffee's gone, and this is my first attempt. Trying to get my head around this is proving very challenging. So yes, thank you very much. It's just the fact it's got to work from this as 0 and then start moving the net. Anyway, I've got some green lights on. That's a major step forward. Oh, lovely. I think I'm getting my head into it now. Get to the stage, I'm very pleased to say, where you just sort of get a feel for the software. You can sort of, you're not even thinking logically about it. It's starting to make a little bit more sense. It's sometime later, and I've got it to do what I want to. Let me show you. As I turn the potentiometer, look. Now initially I managed to set it up fairly simply. Once I've got my head around the fact that this is writing very, very fast and having to read the potentiometer. And just getting them all the first row, then the second, and this fills up and it just carries on. But I didn't like that. I do like a challenge and to overcomplicate things. So as you can see, they fill up different rates at different rates until they all reach the top. And I can keep turning this for the other half, if you remember we talked about, and it's fine, it copes with it. Oh, we've had some struggles, I can tell you. But we finally got there. Pretty colours. Let me briefly mention how I've done this. So there's the first bit that we saw before, and in the loop, every time it loops round, it reads an analogue value from the potentiometer. And having looked it up again, that goes from 0 to 123. Then I create 4 integers. Each LED is represented by the result of that, the analog result divided by 39. If you know, that basically gives you the 13 LEDs that there are. Then I create 4 arrays of the numbers of the actual LEDs along the strip. You can see it starts at 0, green, runs along, then 8, 18, etc, etc, because they're all in order. And I just found that was the simplest way to do it. So there's those 4 loops, just counting up to the right amount for each one, and then it just displays the data. I think it's time to stop another video, 25 minutes and stuff. There'll be another one shortly, where we hopefully will get the sparklies to work. Thanks very much for watching. Hope to see you next time.